All right, welcome everybody to week 9, day 2. We're going to talk about your mods today and about your final project as well. So your final project hasn't changed. You still have to work as a group. Kernichan, what's up? What's going on? You still have to work as a group and put a project together. So your Perforce license is probably going to run out sometime this month. So, I don't know, you can figure out Dropbox or something. I don't know. I did put up a video on how to migrate assets between projects. So if you have one person make like a monster, you can export it. Basically what you do is you create a blank project, you export into it, and then send that to somebody else, and then they export out of that. Because Unreal Engine has, for whatever reason, exporting, but it doesn't have importing from other Unreal projects. So the best way of getting stuff between people is just, you know, if you don't want to use Perforce, which you were having trouble with, is just to use Dropbox or something like that and export your stuff into a blank file. It's not a good solution, but it's a solution. So, yes, you must still keep doing your project. And let's talk about your mods, though. Okay, so the hard deadline for this is of course the end of the semester. So you got 9 weeks left, but you got 2 projects to do. You got your mod, you got your Unreal project. I'm gonna appoint Aaron to be the head of the project, and Aaron, you can delegate. You can come up with a timeline and delegate tasks to people. I think Yui has already got his work done. He did the main menu and stuff like that. It's pretty fantastic. I've already given him full points for the assignment, which is good because I haven't seen the dude in a while. So I don't know. But modding. So who was it? Bedencourt that was working on the Minecraft. Yeah, okay. So yeah, that's cool. That'll be your final mod project for this class as well. That's a-okay. For the rest of you, I would like to see, you know, obviously something a little more difficult than what we did in IS-58. Okay, either larger or harder, one or the other. Either or both, I guess. I don't want you to kill yourselves, you know, stressing out too much over it. But this is a class, and you do have to produce work. It's part of, it's college, you know. If you took too many classes, you know, that's on you. I want to go over your limits for this project. Yeah. So, what can you do? Some ideas that students have done in the past. Skyrim mods, those are pretty popular. We had a couple people do Minecraft last semester. Aaron, did you do like the Lord of the Rings game? Was that you? Yeah, you did the Lord of the Rings mod last year. Basically, any moddable game, you know, is fair game. I've been tempted to make a Valheim mod, for example. Valheim is odd in that it sold 5 million copies, and it wasn't even, you know, obviously it's not done, it's an early access game, but like there's just large parts of the game just missing, you know, and it's early access. I mean, it's not like they promised us a full game, but like it was extremely popular and very, you know, people were playing it a lot back in, like I met up with friends that I haven't seen in 20 years and played Valheim with them, you know, because we're still friends on Steam and stuff, and then it just kind of stopped. You know, the population of Valheim is down to like 20,000 players a day, something like that, up from, you know, down from like 5 million or whatever it was a while back. Hearth and Home came out, and there was a little bump in the player base, but Hearth and Home was kind of minimal. So anyway, my point is that Valheim is actually one of these games that there's a real big potential for modding in it, just because the game isn't done and the developers are releasing stuff slowly. But it's also very dangerous to mod because updates can break your mod, you know, because it's still a work in progress. And if they do something that conflicts with your mod's probably going to lose or cause a crash or something like that. So if you want to do Valheim, that'd be cool. They don't have any official modding support, but people have been kind of knocking on it. It's a Unity game, and so a lot of the Unity tools work on it just fine. Okay, so another idea would be to do something in the console. And so this is something I've done with students in the past. And so this is this is a client that we put together in 2 hours at the end of spring 2020, and you can actually walk around and you can see you can navigate around. It's a 3D world. This is a Wolfenstein-style. There's a wall behind me, so I'm strafing left, strafing right. Let's see that it is in fact a 3D world that I'm in. And the way it works is it shoots out a ray in each direction. Every column in the terminal gets a ray, and it shoots a ray, and it determines how far away the nearest wall is from us. And then it draws a column, highest to lowest, same size, it's symmetrical. If you look at the horizontal plane right in the middle of the screen, all the walls are as tall above it as they are below it. So it's a symmetrical thing, and it just draws a vertical line. And the color of the line, I shade it based on how close it is versus how far it is away to simulate depth, because that makes it look a little more, it gives you depth cueing and stuff. So I'm strafing right here. You can see how that works. And so what it does is for every column, it shoots out a ray. When the ray hits a wall, then it draws a vertical column based on how close or how far it is away. So if it's far away, it gets a little column. If it's close, it's a big column, and that simulates depth. You can see it's not very accurate here because, I mean, we only have a certain number of rows, you know, on the screen. It should more be like a straight line, and I think my math is broken also on it. But that's what happens when you put together a Doom client in 2 hours. So this is an option, yeah. This is an actual real option. Is I will give you the, you can either, yeah, I'll give you the source code, and I want you to mod it. So actually make, this is using my colors library, and it is using non-blocking IO. I'm not hitting anything. You know, you can see it's not super fast. We're getting, what frame rate are we getting on here? Not a great frame rate, but yeah, it's also not terrible. If I were to shrink the screen, I'd probably speed up a little bit. Yeah, so actually make a game. I think it's capped. I think I cap it at 10 frames a second or something. I don't know. Yeah, but like basically modifying this, right? And building, put monsters in, the ability to shoot. You can click using the colors client too. So that could be a fun project. I actually turn this skeleton of a game engine into an actual game. Fix the bugs that there are in it, and stuff. So I want to make a JS game because Unreal doesn't like 2D. Okay, that's fine. So yeah, I'll push this out to all of you. And why don't I make your assignment for Tuesday being fixing this? See if you can fix the fact that the walls aren't. See how they have like this parabolic thing here? It means my math is wrong. So the perspective that I'm doing on this is not right. So fix that. That's your assignment for Tuesday. Let's go over the source code. Okay, so let me sudo. Actually, let's see here. So I've got a math library, and this math library is put together by one of my students, I think. And it does matrix operations, vector operations, so all the stuff that we've talked about before, dot products and cross products, and vector times vector, vector times matrix, matrix times scalar, vector times scalar, all that stuff is done. It does a 2D cross product and a 3D cross product. What's it complaining about here? Order of operations? What's your deal? Braces around a scalar initializer. Okay. Angle mod, which wraps degrees to 0 to 360. Degrees to radians, matrix transposing. Yeah, so Muya did a pretty good job with this. We worked on a lot of this math together in class, but he did a lot more than what we did in class. So props to him. So it's got all your basic matrix math type stuff in there. And then here we got make file. Yeah, all pretty straightforward. Okay, so the source code is in doom.cc, and I apologize for any style issues with this. We literally coded this live in a class, so I haven't touched this since spring of 2021. So what's that? 6 months ago at this point, something like that. Okay, so let's start with this here. So I made a map using text. So that wall that you see sticking out there, that's the player starts, I think, right here, something like that. So there's a wall here, and if I don't know, modify this. Let's see. I can add like a diagonal wall over here. Make, run. So I'm looking south right now. So this is dead south right here. Okay, like that. See, I'm printing out all the information up here, field of view, angle, how long it's taking to render, stuff like that. Distance to the nearest wall, 6.6. And over here you can see the new walls that I put in. So those walls are now in the corner of the room. You can see that they're kind of weird looking. Because somebody's at my front door. Okay. So you can see you can just kind of mess with the map like this. Okay. Start off looking north. Okay. I'm now looking east. And so that's the wall that I just put in there. Okay. So I can look down that pocket. So I moved up here and then looked this way, and you can see in that little pocket there. Okay. So let's go through this line by line. So main runs, turns off the cursor, turns on raw mode, which allows you to do non-blocking I/O. I then set up some callbacks so that if we quit, then we call this bailout function that I made. The bailout function resets the terminal so you don't get those issues where if your program sets the text color to be red and you quit, like you Control-C out, then your text in the terminal is red permanently. So what I did was made it so that if you either quit by hitting quit, or you quit by hitting Control-C, that is this thing here, and when we hit Control-C, call interrupt handler. Okay. Did you guys know that you could do that? So you can set a function to run when your program quits. So just like how in Unreal Engine you can have a function run when you smash into something in C++, you can make a function run when the program terminates. And so whenever the program terminates, it will call bailout, like this. There's only one way that you can get your code to terminate without calling this, and it's a super secret method. All the normal ways of calling exit or returning from main will call this callback. And so all it's doing is turning these things off here. It probably should also probably clean up the screen as well. Okay, then this, have you guys seen that before? Signal? I know Dolan has. It's taken 45. So Signal says what happens if somebody hits, in this case, Control C. Control C is SIG-INT, signal interrupt. So what this is, it's setting up a callback. So it says when the user hits Control C, that's SIG-INT, call this function called interrupt handler. And interrupt handler is right here. So interrupt handler just calls exit. That's all it does. I probably could have just passed exit to it, but whatever. And then exit, when it's called, that quits your program, but exit's going to call bailout, and so it's going to fix up the terminal when it leaves. So yeah, so signal and add exit, those two things together will allow us to clean up after ourselves. Yes, yeah, good. She remembers. Here is a 2D array of maps, and called map. Probably shouldn't call it map. Map has a different meaning in computer science, but like I said, I'm not. Forgive me for any style issues here. So what I'm doing is I'm making a 2D array, and this is how people actually made maps back in the day. When people were making maps for like Wolfenstein, this is actually how they did it. They had a text editor, and the text editor would be a big 2D array, and you could put monsters on the grid, and they actually had graph paper, and they would graph it out and stuff like that, and then they would render it. So this is actually legitimate first generation first person shooter type stuff. The old Castle Wolfenstein Doom 1 days. So you can make a little maze or whatever. I'm then creating the main player, which I'm calling Doom Guy, of course, because it's a quick reference. We went back in time and sold this game, we would make lots of money. That it's interesting, because nobody made this for terminal, right? So like there was never like a big hit terminal first-person shooter like this. There were top-down strategy games. NetHack, of course, was very big, but it's like you're looking at this. You're like looking at this from above. Nobody ever did like rendering, like 3D ray casting and things like that inside of a terminal. I mean, nowadays you can find a couple weirdos doing it, like me. But back in the day, I don't know. There probably was. Yeah, I remember seeing a demo where it like ray traced an image, but it was all in ASCII. It wasn't in color, so it looked kind of garbage. Go back in time and make Minecraft. Make it a Linux exclusive. Yeah, it's really interesting to think about, because there's only a few things you actually need from a terminal, like PuTTY, that we didn't have back then. Mouse support, I don't know when mouse support was added. 24-bit color is actually within the last couple of years. So back in the day, the color support was really bad. And so all they really needed to do was have all the terminal makers, like DEC was the big maker, just get together and just say like, all right, we're just going to publish this specification. And everything was just always very ad hoc. Like there were all these different standards, they didn't talk to each other. And if you got accent characters to work on one terminal, it wouldn't work on another, because they didn't have Unicode back then, right? They had ASCII, but if you wanted something beyond ASCII, like to do Windows and things like that, then that's extended ASCII. And so there was, ASCII is 128 characters, right? Then extended ASCII was the other 128. And everybody had a different idea for what should go into that code page. Some people had like little window characters so you could draw straight lines and things like that, and have windows on the screen and stuff like that. That was very common, but it wasn't universal. Everybody had a different idea of what to do, because if you're from Russia, Or if you're from Germany, or if you're from France, you have different ideas about what characters are absolutely essential. If they had made UTF-8 back then, that would have been a game changer. Like if we had UTF-8 Unicode from the beginning, and if people had just been like, all right, instead of hard coding the second code page of 128 characters, let's make that high bit just mean more to come. Have that high bit just say, all right, there's going to be more to come, and you just get everybody together, and everybody who wants a code point, like an accent grave or an umlaut or something, just everybody, you just get everybody together, all the French people and German people and Chinese and people who make poop emojis, you get them all together, and you can have infinite numbers of possible characters if you want. You just keep having the high bit mean there's more to come, and then you just make the more common characters up at the front, so it'll be compressed a little bit more. And if they had done that from the beginning, man, the world would be a different place. Because even today, like if you have a Chinese name and you try using it, maybe not most, but a lot of, they just don't work. Unicode is pretty well supported these days, but even still, you try entering your Chinese name at a bank or something, it's like, nope, use ASCII. Sorry. So it's just because of their internal systems. If any point along the way is ASCII and you try stuffing UTF into it, everything explodes. So one of the nice things about ASCII is you can do things like say, is alpha, right? Is what you gave me a letter. That's really hard to do in Unicode, right? Like, is poop emoji a letter? No, I don't think so. But like, what about like an E with like a bar over it? What about the hiragana? Is that a letter? Is that alpha? What about Chinese characters? Is alpha? Should is alpha be true for wall? It's like all these nice little things we have that we're used to from working with that. Because like when you're creating an account at a bank, they don't want you to have like a star in your name, or or like an exclamation mark. You know what I mean? Like they want to just vet it and just make sure that it's just letters and maybe a hyphen or something, and maybe a single quote or something. And with Unicode, all that stuff gets a lot more complicated, and it throws it right up in your face because like you don't even have it for English anymore. So if they had done all that stuff from the beginning, and you would have been able to just in your deck terminal from the 1970s, been able to be like, yo, here's my name, and it worked, man, the world would have been a very different place, I think. And all they had to do also was just add in future support for 8-bit color, and mouse and sound. Sound is the one thing that's missing. There's no way to play a sound through a terminal. If they had done that, like, it's, probably GUIs would have taken off, but it's also possible you could do the GUIs inside of a terminal also. You can have what's called a TUI, text user interface. So it's an interesting question. Like, what if, you go back in time? But all the vendors, like, didn't get along with each other and sort of sabotage themselves. So now terminals are only used by elite hackers, like Stephanie Dolan. So, yeah, but this is how maps are made. So the only thing really that needs to be done, like to have, there's maybe a frame buffer that you could write to speed up draw calls. I don't know. I can think of different things. But what happened instead was we got X Windows, which was the Unix equivalent of Windows, and it was kind of terrible. I used X Windows systems back in the day, and they're kind of terrible. But the nice thing about them is that you can have your Windows, like this thing here, launched from a different computer. So you could run a program on the server, and it would bloop, and it would pop up like your calendar, but it's actually on the server. And so you're running things locally, but it's on the server. So if you make changes there, it's on the server, and then you can go to a different system and log in again, and all the changes you made are there. It's your like your remote desktop client kind of thing. And that could have taken off, except that was terribly implemented as well. It's really slow. Okay, and they're still working on the re-implementation of it. So Wayland is a simpler replacement for X Windows. GNOME and KDE are expected to be ported to it. So, you know, what year is it? 2021? So that's kind of the direction that the world went in. And, yeah, I don't know. It's interesting to think about. So you can see, you can basically launch things and these windows pop up. When you click on them, it sends messages to the server, and so it's kind of laggy and stuff like that too. So, all right, so let's go through this. We create the player. The player is somewhere. Where's the player? Class player. What a player? No. Grep player. That's a Doom. Let's see, it's a struct. There we go. Okay, so the player starts off at location 5-5, hit points having 100, starts off having a shotgun. There's an enum for the weapons we have, and you can extend this. These are all have to be powers of 2, of course, when you're doing a bit field. You can have the most 32 weapons, I guess. 100 bullets, movement speed of 1 meter per second, rotational speed of 90 degrees per second. Starts off looking north. So if we wanted, we can start this off looking south. Field of view of 70. Let's try changing that. Maybe. I don't know. Okay. So the angle updates in real time. You can. I think I have a key to change the field of view in real time also. Okay. So let's go through this. So we turn on walking mode. We start off with the assumption of a 30th second. So this is how you get the current time in C++. Modern C++. You might be used to using time to get the current time, which gives you seconds since the beginning of time, which was January 1st, 1970. You can also use clock. Clock gives you microseconds since the program was run, but this is the better way of getting the time. This is the C++ way of getting the current time. Main loop. So we count how many frames have gone by. And so just up top, we're just going to print out the stats for our own edification. So it prints out our X and Y location, what direction we're looking, what field of view we have, how long it's been since the last frame. And then we print out the distance to the wall. And so I wrote a traceline function. And the traceline function says, start from my starting location, from my angle. So if I'm looking east, west, north, south, whatever, and it passes in the map, tell me how far away the nearest wall is. So as you look around, you'll see the distance to wall decreasing as you walk up towards a wall. And we copy the Doom guy for some reason. Oh yeah, okay, I know why. So we duplicate the Doom guy, and then we read a key from the keyboard. If they didn't type in anything, or is nothing, it'll return error. So if show equals error, nothing was typed this frame. It's going to give me a warning. Statement has an empty body. Fine. How about now? Still mad at me? Fine. Okay. No, Okay, so yeah, if you want to have something happen when nothing was typed, that's return. So quick read is a function that returns whatever key is set on the keyboard, and it does so without waiting. And so this is really nice if you want to make a video game, because blocking I/O sucks for a video game. So what happens at every frame, it's going to return error, 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 and then you hit Q, and then you just check to see if what was returned was Q. If it was, it quits the game. If you have WASD, so WASD is your standard first-person shooter movement commands. W is going to move you forwards, and there's a little bit of math here, right? So we've got the angle. So if we're looking to the east, the angle is 90, I think. And so that means we want to travel in the positive x direction, right? So we get the cosine and sine of these things, and then there's a little bit of trig that goes into figuring out what direction they move. Good news is this works fine. So he moves, so the sine of 90 degrees is 1, right? And so it's going to move 1 in the x direction, normalized by delta t. Do you guys remember this from IS-50? That you have to normalize speed based on frame rate. Duncan, Betancourt, Dolan, do you guys remember this? Delta time, event tick. Every time you do something every frame, you need to multiply by delta t. Otherwise, you'll run faster with a higher frame rate and run slower with a slower frame rate. So the movement speed is per second, not per frame. So you have to divide by frames per second to normalize it out. Okay, so a little bit of trig. Basically, you can plug in 0, 90, 180, and 360 and see that this all works. If you're facing northwards, the degrees is 0, so cosine is 1, and so you're going to move up in the y direction. Yeah. So if c is 1, then y goes down because remember y 0, 0 is the top left. So y decreases as you move upwards. So that's a little bit of trig that handles movement. You don't need to worry about that, I don't think. E and R adjust the field of view, and I did that because I was wondering if the field of view was the reason why it broke. So, or not broke, but it just doesn't look very good, you know? Like you got this weird hyperbolic curve on the things. Oops. So I played around with that a little bit. So as you mess with the field of view, it's like you zoom in, right? You see that? Field of view is down to 40, you know? It's like I zoomed in, and then if I zoom out, I think it might have more to do with the fact we don't have square pixels. We have rectangular pixels. So we're doing a fisheye effect now. So that doesn't look terrible, actually. 160-degree field of view. But you see how all these things look curved? Yeah. That's what I'm talking about. Yeah, it's like that's a flat wall back there, but it looks like it's curving away from us. You know what I mean? So that's what I want you to fix for your homework assignment. Find out what's wrong with it. Fix it. Okay. So E and R adjust the field of view. Up and down, left arrow and right arrow are going to rotate you left and right. And so it just increases or decreases the angle. You have a rotational speed of 90 degrees rotated per second. That also gets normalized by delta t. So that all works too. Then it does an angle mod so that if it goes past 360 or below 0, then it snaps back to 0 to 360. Just to keep everything sane. And then finally, we have collision detection. So right here, what it's doing, and this is why we made a duplicate of our Doom guy. So basically, we record where we were last frame. Our direction, our angle, all that stuff from last frame is saved. And then, if we ever walk over if we ever walk over a wall, it bounces us. So you see what we did here? So if our new spot, because it's just looking up our spot based on our X and Y location. So if we're at 5.5, 5.2, 5.9, it's still 5. And so we're technically not really leaving our square until we leave the square. Once we cross over into 6, then we're in a new square. So what it's doing is saying if we have entered a new square and that new square is a wall, because we got a map, right? So as we walk around the world, this is a top-down view. If we ever walk over a wall, then what it does is it just sets our stats back to what it was on the previous frame. Where did you go? There. And that's not good, by the way. That's probably... I should add a to-do on this. Actually, I can do that right now, actually. So what I'm going to do is say if they've walked into a wall, I'm going to set their position doomguy.x equals old doomguy.x and doomguy.y is equal to old doomguy.y. So this is better because before, like if I was rotating the camera and I hit a wall, it would actually snap the camera back to where it was before. And if I had taken damage this frame and I walked into a wall, it would undo the damage too. So I could become invulnerable by sitting there and just bumping up against the wall, and monsters, which don't exist yet, could keep shooting me, and I'm like, nope, I'm invulnerable. I'm invulnerable. I'm rubbing my face on the wall. I can't take damage. So we fixed that by just having the position reset rather than resetting the entire character backwards in time like Tracer or something. So yeah, that's a good fix to that. All right. Double check this, make sure it works. Try walking into the wall. Distance to the wall decreasing, won't let me go through. Backing up, you can see the distance to the wall there. Okay. I will try running into it. The distance decreases down to 0.08 and it's not letting me go through. So that's a very simple way of doing collision detection, okay? That's what I'm talking about. I should have cleared the screen, shouldn't I? Okay. Bailout, scout, reset. Fill the screen like this, and then quit. And good. It's not red anymore. Oh, is the cursor gone? Maybe the cursor was gone. Control C. I don't have a cursor. Okay, let's fix that too. Okay, so this function gets called when we quit the program. Tell Linux to call bailout when we control C out. So we need to turn the cursor back on. And quit. And now we got a cursor again. Cool. Am I just no? What do you have a question about? I'm kind of just going through this code so that you kind of understand the lay of the land for this. Okay. So this is a function that gets called when the program quits, and it just turns the mouse off. It turns off non-blocking I/O. It turns the cursor back on. It resets the colors. You don't have to write this from scratch. You're gonna have to mess with it. If you want, if fixing the graphics engine is to would it be possible to refactor the entire thing? Yeah, that's kind of what I was getting at. Is that I think it would be a fun project to mod this, turn it into a working game. This is a very fast proof of concept that you can do Doom inside of Putty, which is not normally done, right? Normally you do 3D games on a computer that has a 3D graphics card and a frame buffer and not on a server in Fremont. Like, this is not normal, right? But it's amusing. It's amusing as hell. So we're doing it. I'm getting an OCD reaction looking at how you code it up. What's the matter with it? What is your OCD triggering on? So we need to add in network, AI, physics. Yeah, I just put all those things down when I hacked it together. I just kind of made a list of like where things are going to go to do. Yeah, so this form of collision detection is not bad. The first 3D game engine I wrote didn't use this. What happened was I would just move everybody. Everybody would move according to their velocity. And then if there was a collision, I'd basically move everybody in the world. So all the cars or whatever, they'd all move. And then I would check to see if any of them were overlapping. So I had kind of a hash table over the whole world. I would go through each bucket of hashes and see if there was any overlapping bounding boxes or bounding spheres inside of there. If there were, I would move them apart. So like if a car hit a wall, I would pull the car back out of the wall. The trouble with this approach is that what if something moved into the spot that you just moved the car back into? Now you've got another collision. And that's a hell of a problem to try and resolve. And that's why like you'll fall through walls and things like that. You move backwards and now there was a truck that came in behind you when you ran into the wall and moves you back into it and you fall through the world. And I spent so much time trying to get that to work. A better system is just to move one thing at a time. And if it hits anything, just move it back where it was before. Or if you want to be smart about it, you do a trace line, you find out how far you can move, and then you come right up into the furthest spot you can move. Or not. Like, as it is, if the frame rate's high enough, you'll get close enough. It doesn't really matter. The design of the codebase. Yeah. And the designs. I mean, you're welcome to take issue with all sorts of things. Like the player isn't a class or anything; it's just a struct. Everything was done based on coding speed. So yeah. So here's the actual rendering. Okay, so let's do this. Here's how it renders a frame. So like I said, the way that it works is that you can think of the terminal as having a bunch of columns because a terminal has a bunch of columns on the screen. And what it does is it knows how many columns there are on the screen because it calls right here. It gets the size of the terminal. So it knows how many columns are on the screen. Okay. And so here's how the rendering works. For every column on the screen, it does a trace line in that direction. And that's probably where the bug is or something. I don't know. It's one of the possible places for bug. So you've got a field of view that's supposed to that's the cone of like what you're looking at. And what it's going to do, it's going to shoot a trace line. Okay, so that centers the field of view over the center line of the screen. So on the center column of the screen, it's going to shoot a trace line straight forward. When you're one column left or one column right, then it's going to be a couple degrees to the left or right. So if your screen encompasses 90 degrees and you have 90 columns, then each column is 1 degree. And so the very center column on the screen is straightforward, and then the columns to the left and right are 1 degree left, 1 degree right, And so it's going to shoot a trace line forward, shoot a trace line to the left, a little bit left, a little bit left, a little bit left. And it's going to sweep this trace line across the entire world over and over again, trace line, trace line, trace line, trace line, trace line, and find out how far away the world is on that column of the screen. And so that's what it's doing here. For every column on the screen, it does a trace line, and it finds out how far away the wall is in that direction. Okay? And yeah, so from my location in this direction, passing the map, it does a trace line. And the trace line simply walks through the data structure. Normally you would have what's called an acceleration structure to make a trace line faster. I do it sort of garbage mode. So it just moves 1 centimeter at a time through the world. So it walks forward a centimeter. Did I touch anything? Nope. Keep going. Walk forward a centimeter. Did I touch anything? Nope. This is garbage, by the way. This is a horrible way of doing it. There's no acceleration structure whatsoever. It's just, it's fine because we have a CPU that runs 4 billion times per second. So it works out. The world's 10 meters by 10 meters. It does 100 of these per meter. So the most it'll do is 1,000 steps times 90 field of view. 90,000 lookups is not great. At the same time, it's not the end of the world either. So, and then, so do you guys understand this part? This is the heart of the renderer. You really have to understand that. Do you want me to switch into OneNote and explain it, or do you understand this? For every column on the screen, we shoot a ray in that direction and find how far away the wall is. So if there's a wall in front of us, it'll go a little bit. If there's a far off wall, it'll travel for a while and hit a wall, and it'll tell us it's 10 meters away or something. Okay. So let me give you a top-down view of this process. It's kind of cool, I think. I don't know. I didn't invent it. It's a very common algorithm. So new page 10.7.1. So let's say that we've got a world. This is top down. This way is north. Yeah. And we got a player here. Player's looking in this direction. And I don't know, there's like a wall here too or something. A couple crates or something. So do you guys understand? We're looking down at the world from above. We're in a room. There's a box. That's it. Okay. So this is a camera, right? You can think of this as a camera. Usually you actually have a camera object. We don't. It's just the player is the camera and the camera is the player. And we've got a field of view. You guys know FOV settings on a game, right? Like you know what I'm talking about when I talk about field of view? All right. So this here would be, so a 90-degree field of view would be like that. So this is like a 80-degree field of view here. Something like that. Okay. So the direction we're looking is this. So what we're going to do is there's a function called traceLine. And so traceLine takes in a starting location and a direction. And then it returns how far apart. So from here to here, it's going to return you're 5 meters away or something like that. You guys get that? You've used trace lines before, right? Line traces and stuff like that. So yeah, I wrote a really, really horrible trace line function. Okay, so what it does is, so in the direction you're looking, it shoots a trace line. And it's like, okay, that's 5 meters away. And then it's going to shoot another trace line 1 degree left of it, and another trace line 1 degree left of it, another trace line 1 degree left of it, 1 degree left of it. And so it's going to basically write down, okay, this one's 4 meters away, this one's 4.1, 4.2, 4.3, 4.4, this one's 5 away. So for every column on the screen, it's going to have a number. This one's 6 meters away. It's 7 meters away. This one's 2 meters away. Yeah. 1.9. 1.8. 5 or something. Okay. Based on the security guard assignment, yeah. I mean, all these tools that we talk about are very common. Like, they're just used everywhere. You know, the fact that my trace line is not efficient actually doesn't matter because the CPU is fast enough to do them all. At our the limiting rate is actually drawing it all to the screen. Rasterizing a image to a screen over a network connection in 24-bit color is not fast. This is not a super high-speed renderer. But this part here is fast enough for our purposes, so we do it. So do you guys get this now? So we're spraying trace lines across our entire field of view. So our entire field of view, basically every degree has a trace line coming out of it. That makes sense? And so the first thing I did when I did this is I just printed the screen. It'd be like 4, 4.1, 4.2. I just printed it. So I didn't have any rendering at all. I just printed the numbers. 4.3, 4.4, 5, 6, 7. You know, I basically just printed out all the results of the trace lines. And from that, I could actually tell if it was working. Because it went like, da, 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 da. Okay, so that's the wall getting further away. And then, oh, there's a 2 and a 1.9 and a 1.8. There's the box, okay. And then there's a 5 and a 4. Do you see that? And so I was able to rotate around, move around in the world, and just by looking at the numbers, I could actually tell that it was working. Is that more taxing on the CPU? Yeah, there's... this is not a great algorithmic design. Yeah, for a lot of reasons. Yeah, it is entirely taxing on the CPU because there is no GPU. There's no GPU acceleration of the what we're doing here. It's all running on a CPU in a data center in Fremont somewhere. And I'm not using any acceleration structures. I should have a data structure to make the trace line faster, and I don't. But I don't care because it's fast enough for our purposes right now. So, good question though. So what we do you guys understand how this is like the result we get? So like all this stuff we do, we're going to get a result like this. 4, 4.1, 4.2. These are the distances at every column on this for the screen. Are you guys with me? So all these numbers we got here, I'm just writing down here. That's the output of phase 1. You just get, it's like we're shooting out a radar, like boing, 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 right? And this is how radar works. Like it just sends out rays and it sees how far it takes to get a signal back. It's literally how radar works. These are just distances. Yeah, this is the distance. Each of these rays is from the player. Then, watch this. Let's say that I have an equation, and this equation is probably what's bad, and you guys should fix, but let's say I have an equation that says draw a wall of height equal to 8 minus distance. Watch this. So what's 8 minus 4? 4. I'll answer that question. Okay. And then 4.1 is going to be a little bit closer. 4.2 is, or sorry, I'm doing this backwards, aren't I? No, yeah. 4.1 is going to be a little bit smaller, I should say, not closer, because it's further away. 4.2 will be a little bit smaller. 4.3 is a little bit smaller. 4.4 is a little bit smaller. 5 is even more small. 6 is even more small. 7 is even more small. Then 2, 8 minus 2 is 6. 1.9. 1.8. Then 5 is back down to like this. And 4 is like a little bit bigger. Okay, so this is our view. This is a first-person shooter now. Do you see that? This is the view of the player here. As he's looking at this warehouse, there's a wall that gets further away, and then there's a box that's kind of closer up here. That's the box. That's the wall of the warehouse receding in the distance. I should probably draw them next to each other, but that's, you know, that's it. Just at every column, I make a rectangle. I draw a number of pixels equal to 8 minus the distance. Do you see this? So this is, do you understand? This is like the player is here and the player is looking out this way. This is now a first person view. Right? And so here's the box closer to us, here's the wall of the warehouse receding in the distance, and then here's the wall behind the box. You guys understand? Yeah, just like that security guard that's spraying the trace lines out. Yeah, except we're using this to render. Okay. Now the trouble we're getting, I think part of it is because we don't have decimals, right? Because the rows are all integers, so I think that might be part of the problem. And so you might want to do some sort of like fancy lerping or something for your assignment to make these walls look right. Because the problem is this. I mean, this seems to be working all right. You know what I mean? Like as I move around, like you can see, I'm moving around the wall. Like as I move around it, you can see as it gets further away, that column of colors gets smaller. This wall is further away, so I draw a smaller column. Things that are closer get a bigger column. Okay? The issue that I'm talking about is this, where it looks like a hyperbolic curve, right? And so there might need to be some sort of like interpolation there, where like if it should be only 0.1 down, then have the colors blend or something like that on the you know, edges of it. I don't know. This is what I want you to fix. Do you think you can, or is it too hard? Would you rather do something else with this? Make a monster? This is a good introduction to how like old school renderers work. Modern renderers don't do this anymore, but it's good. I have no idea how to even start on this. Okay. All right, propose something else. So what this is doing is for every column, it shoots out a ray. That's the distance. And it draws for every row on the screen, it's going to draw, let's see, where is it? Distance. It draws a ceiling above. It draws the gray ceiling above, the gray floor below, and then it draws red for the wall itself. And the further away the wall is, the darker it gets, and that's what makes that happen. And that's it. That's the entire game. That's it. So yeah, it shoots out a bunch of trace lines, and then it's going to loop over every row on the screen. It moves the cursor to that row, that column, and if it's above the wall, then it prints gray. It'll do gray. If it's in the wall, it does the red. If it's below the wall, it does the gray again. And so it just loops down the entire column. drawing a bunch of gray, drawing a bunch of red, then drawing a bunch of gray. The amount of red that it draws is based on this number here, wall percentage, and that's how that's that formula that I showed you here, kind of, where like the further away a wall is, the smaller it is. Ten is the maximum distance, I think. Yeah. And then, yeah, so the wall percentage will vanish down to 0 when you're at 10 meters away. And when you're 1 meter away, it's at 100% of the screen. And then the ceiling percentage is the area above the wall and the area below the wall. That's it. That's the entire render. That's the whole thing. It's only like 4 pages of code, you know, with some debugging stuff still in there and stuff. That's the whole thing. 192 lines of code, 4 pages of text. User input, non-blocking I/O, colors, 3D rendering. That's the whole thing. Okay. Can you do that for the modding project? Sure. Then let me come up with a new assignment for you then instead. Have you guys made a main menu yet for your games in Unreal Engine? You stole Michael's? Okay. Sort of? Okay. Why don't we just make that your thing? So make it so that when you hit escape, splash screen, when you launch the game, it's in the, you know, it has like a splash screen and like start, and then when you hit escape, it puts up one. It should take you about an hour. It's called stealing. Yeah. Well, yeah. That's how it works. Been having issues sending to my laptop for submission. Their assets. Those are the assets you couldn't upload. Yeah, it's fine. But for this homework assignment, you just screenshot and put it up on Canvas. You're good to go. Okay. So to make a main menu, when you launch the game, main menu's there. You click on Start, plays the game, and if the user hits Escape, it pauses the game and goes back into it. Okay. Took you more than an hour? It could. It's not too. I have a tutorial I can put up as well. I found a good tutorial on YouTube. So I think anyhow. So this I think would be a good project to modify if you want to do your mod in this, because you could add monsters to it. You could make it when you click it shoots a shotgun or whatever, and you can actually make a playable first-person shooter inside a putty, which is really, really hilarious, to be perfectly honest. Okay, so that's it for today, guys. Sorry we ran a little bit over. It should be fun though. Okay. All right, I'll see you guys on Tuesday. Peace out.